Hello friends, this is Vishnu Adole. Welcome back to my YouTube channel. Friends, today we are going to discuss a very important topic from the inorganic chemistry, and the topic is concept of hybridization. Friends, this topic is very important for the students who are appearing for the exams like JEE, NEET, CET, NET, SLATE, GATE, IIT-JAM and PhD entrance examinations. Number of questions are repeatedly asked in these competitive examinations are based on concept of hybridization. So this topic is very important for the students. Friends, to predict the hybridization and shape of the molecules belonging to the p block elements, valence shell electron pair repulsion theory is used. And by this theory, one can predict the hybridization and shape of the molecule. Friends, according to this theory, shape of the molecule is determined by repulsions between all the electrons. All electrons means bond pair electrons and lone pair electrons. Friends, according to valence shell electron pair repulsion theory, molecules arrange the electron pair in a such a way that they will create minimum repulsion, and the minimum repulsion will give high stability to the molecules, and this phenomena is very important for arranging the electron pairs in the molecules. Friends, in this video I am going to provide you simple trick to find out the hybridization. Friends, I have written a formula here which is hybridization is equal to number of sigma bonds plus number of lone pairs. Friends, here number of sigma bonds can be easily predicted by looking at the molecular formula of the molecules. And to find out the number of lone pairs, we have to use this formula. Number of lone pairs is equal to valence electrons minus number of bonds divided by 2. And here we have to consider both sigma and pi. And in case of hybridization, you have to consider only sigma bonds. And sigma bonds can easily predicted by looking at the molecular formula. Friends, by using this simple trick, you can predict the number of lone pairs on central atom, hybridization and shape of the molecules. So you can easily answer question based on this concept. Friends, let us see what is the answer from this formula. Friends, the answers from hybridization formula are like this: 2, 3, 4, 5, 6, 7. If answer is 2, hybridization is Sp. For 3, it is Sp2, 4, Sp3, 5, Sp3d, 6, Sp3d2, 7, Sp3d3. So, by knowing the proper answer, you can predict the hybridization of the molecules. Friends, for Sp hybridization, shape is linear. For Sp2, trigonal planar. For Sp3, tetrahedral. For Sp3d, trigonal bipyramidal. For Sp3d2, octahedral. And for Sp3d3, pentagonal bipyramidal. Friends, so if you know what is the hybridization of the molecules, you can predict the geometry of the molecules easily. And to predict the hybridization of the molecules, here I am providing you simple trick. Let us see this concept. Friends, when the molecule is having shape like this, it is called as V-shaped or angular. This one is called as pyramidal, in which one of the position is occupied by lone pair. So 3 bonds and 1 lone pair, the shape is pyramidal. Whenever it is looking like this, it is called as seesaw. Friends, you have seen the seesaw in garden. When shapes of the molecules is like seesaw, the molecules are called as seesaw molecules. This one is T-shaped. This one is square planar. You can see here, this all atoms are in one plane and it is forming square, so it is called as square planar molecule. And this one is square pyramidal. This is square and this one is forming pyramid, so it is called as square pyramidal. Friends, we have to remember all these shapes for hybridization purpose. Friends, I would like to discuss a very important information about trigonal bipyramidal structures. Friends, out of 5 bonds which are present in the trigonal bipyramidal, these 2 bonds which are exactly 180 degree away from each other are called as axial bonds, and and 3 bonds which are forming the trigonal planar shape are called as equatorial bonds. So out of 5, 2 are axial and 3 are equatorial. Friends, one thing which I would like to share with you is the position of lone pair in the trigonal bipyramidal structure. Whenever lone pair is present, we must know where to place the lone pair. Let us discuss this concept. Here I have placed the lone pair at the axial position, and in this I have placed the lone pair at equatorial position. Friends, when the lone pair is at axial position, it is having 90-degree angle with 3 bonds. See here, here it is 90 degree, here also it will be 90 degree, and with this it will be 90 degree. So 3 bonds are having 90-degree bond angle with the lone pair. So lone pair is having repulsion by 90 degree with the 3 bonds. Let us discuss when the lone pair is at equatorial position. When lone pair is at equatorial position, it will have 90-degree bond angle with these axial groups. So here it is 90, here it is 90, with this it is 120 degree. So here only 2 bonds are 90 degree with respect to lone pairs. In case of this, 3 bonds are 90 degree with respect to lone pair. This means that 3 bonds are close to lone pair in this structure. Here only 2 bonds are close to the lone pair. By looking at this structure, we can easily say that lone pair is having more repulsion in this case as it is closer to the bond, and here it is having less repulsion. Less repulsion means more stability. So we have got the answer, that is lone pair will take equatorial position when it is trigonal bipyramidal geometry. Friends, to predict the hybridization, we must understand this concept. I have written here p block elements: boron family, carbon family, nitrogen family, oxygen family, fluorine family, and the inert gases. Helium is not written because it is not important as far as hybridization is concerned. Friends, we can see that here boron family is 13 group members, carbon family is 14 group members, nitrogen 15, oxygen 16, fluorine 17, and this family inert gases 18. By looking at these number, you can easily predict the valence electron present in the p block element. See here, this 13 group element, boron group elements will have 3 valence electrons. See this number 3 valence electrons. This one will have 4 valence electron, 5 valence electron, 6 valence electrons, 7 valence electrons, and 8 valence electrons. And we know that in our hybridization formula, valence electrons are very important. So we have to remember this thing. Boron family will have 3 valence electrons, carbon family 4, nitrogen 5, oxygen 6, fluorine 7, and the inert gases 8 valence electrons. Friends, let us solve the problem for BF3 molecule. Friends, in BF3 molecule, boron is surrounded by 3 fluorine atoms. It means that it has 3 sigma bonds. Boron is the central atom. Boron family we know having 3 valence electrons. Let us find out the lone pair. We have the formula for the lone pair. So 3 valence electron minus 3 bonds, 3 minus 3 divided by 2 is equal to 0. So number of lone pairs on boron atom 0. Let us find out the hybridization. So hybridization is equal to number of sigma bonds plus lone pair. So boron is having 3 sigma bond with 3 fluorine atoms. So 3 sigma bond, 0 lone pair, 3 plus 0 is equal to 3. So 3 means sp2 hybridization as I discussed earlier. And for sp2 hybridization geometry is trigonal planar. So BF3 is having sp2 hybridization for boron atom, and therefore it is having trigonal planar geometry. Let us find out for CH4. Friends, carbon is having how many valence electrons? 6. So number of lone pairs is equal to, carbon is having 4 valence electrons. So number of lone pair is equal to 4, and number of bonds are 4. 4 minus 4 divided by 2 is equal to 0 lone pair on carbon in CH4. So hybridization is equal to number of sigma bonds 4 plus lone pair 0 is equal to 4. So 4 means sp3 hybridization, and for sp3 we know that geometry shape of the molecule is tetrahedral. Friends, let us have discussion on some more examples. Let us discuss PF5. In PF5, phosphorus is surrounded by 5 fluorine atoms, and we know that phosphorus is belonging to nitrogen family having 5 valence electrons. So 5 valence electron minus 5 bonds divided by 2 number of lone pairs 0. So hybridization is equal to number of bonds 5 plus number of lone pairs 0 is equal to 5. 5 plus 0 5. 5 means sp3 dehybridization, and friends, we know that sp3 dehybridization will have trigonal bipyramidal geometry. Let us find out the hybridization for Sf6 molecule. Sulphur belonging to oxygen family will have 6 valence electrons. So number of lone pairs will be 6 valence electron minus this 6 bonds. 6 minus 6 divided by 2 is equal to number of lone pair 0. Hybridization is equal to 6 bonds plus 0 lone pair is equal to 6, and for 6 we know that it is sp3d2 hybridization, and for sp3d2 hybridization the geometry is octahedral. Geometry is octahedral for sp3d2 hybridization. Friends, let us find out hybridization for iodine in IF7. Iodine belonging to fluorine family having 7 valence electron. Let us find out the lone pairs. 7 valence electron minus 7 bonds. 7 minus 7 divided by 2 is equal to 0 lone pair, and hybridization is equal to 7 bonds plus 0 lone pair is equal to 7. 7 is equal to sp3d3, and for sp3d3, friends, it is pentagonal bipyramidal. 5 fluorine forming pentagon and 2 fluorine forming bipyramid, so it is called as pentagonal bipyramidal geometry. Friends, as we predicted, BF3 is having sp2 hybridization, and in BF3 boron is trivalent. Boron is attached to 3 fluorine atoms. It means that all the compounds from the boron family which are having 3 bonds will have sp2 hybridization. So BH3, BCl3, LCl3, LH3, GaCl3 will have sp2 hybridization with that geometry. Let us consider with geometry trigonal planar geometry. Let us discuss CH4. Friends, we know that CH4 has sp3 hybridization in which carbon is having 4 sigma bonds with 4 hydrogen atoms. Now, these compounds in which carbon is having 4 sigma bonds will have sp3 hybridization similar to CH4. SiCl4 will also have same hybridization as it is having 4 sigma bonds. Now, for PF5 molecule, we have predicted the hybridization, and it is sp3d, and PCl5 is similar to PF5, so it will also have same hybridization, that is sp3d. Friends, let us find out the hybridization of NH3. NH3 is having, nitrogen is having how many valence electrons? 5. So number of lone pair is equal to 5 minus 3 bonds divided by 2. 2 divided by 2 is equal to 1. So nitrogen atom having 1 lone pair in NH3. So 3 bonds plus 1 lone pair is equal to 4, and 4 means sp3 hybridization. Friends, here I would like to point out one thing. Whenever sp3 hybridization is there, having 1 lone pair, the geometry is pyramidal. Now friends, PF3 is similar to NH3. In NH3, nitrogen is having 3 bonds with 3 hydrogen atoms. Phosphorus is also having 3 bonds, and both are from the same family, from same group. So PF3 will also have same hybridization and same shape. See here, sp3 hybridization and pyramidal geometry. Here also pyramidal geometry. Both are having pyramidal geometry. Friends, let us discuss the hybridization of chlorine in ClF3. We know that chlorine will have 7 valence electron as it is member of fluorine family. So 7 valence electrons minus 3 bonds divided by 2, valence electrons are 2. 3 bonds plus 2 is equal to 5. H is equal to 5 means it is sp3 dehybridization, and for sp3d the structures are like trigonal bipyramidal. Now friends, one thing is important here. This ClF3 molecule is having 2 lone pairs on chlorine atom, and as it is trigonal bipyramidal, the two lone pairs will take equatorial position, and this concept is discussed by me in the earlier part of this video. So two lone pairs will take equatorial position and three fluorine atoms are like this: two fluorine axial, one fluorine equatorial. So lone pairs are placed in such a way that they will create minimum repulsion. And if we neglect the lone pair, ClF3 will look like this, and therefore it will have shape, that is T-shaped structure. Let us find out the hybridization of sulfur in Sf4. We know that sulfur is having 6 valence electrons, 6 minus 4 bonds divided by 2, number of lone pair 1. Hybridization is equal to 4 bonds plus 1, 5. 5 is Sp3d. Friends, again Sp3d hybridization having one lone pair, and lone pair will take which position? Equatorial position. And if we neglect the lone pair, the structure of Sf4 will look like this. And friends, we know that the structure is similar to seesaw, which we see in the garden. So the shape of this Sf4 is called as seesaw. Friends, one thing I would like to point out here. I would like to point out hybridization of molecules containing oxygen atom. Oxygen not as a central atom but as a part of molecule. Friends, we know that oxygen can form sigma as well as pi bonds. And one thing we know, pi bonds are formed from unhybridized p orbital, therefore they are not considered in hybridization. We are finding out hybridization, and pi bonds are not part of hybridization, therefore they are not counted in hybridization. Now I will discuss molecules in which oxygen is forming both sigma and pi bond. Let us discuss XeO4 molecule. Friends, xenon is belonging to inert gas family, and we know that inert gas family is having 8 valence electrons. Now friends, here in this case oxygen is forming sigma as well as pi bond. 4 oxygen atoms will form 4 sigma bonds and 4 pi bonds. So 8 valence electron in xenon minus 4 sigma plus 4 pi, that is 8. 8 minus 8 divided by 2, number of lone pair will be 0 on xenon in XeO4. Therefore hybridization is equal to sigma bond plus lone pair. Lone pair is 0. Now oxygen is forming 4 sigma bonds and 4 pi bonds. Pi bonds are not considered. 4 sigma bonds means 4 plus 0 is equal to 4, and 4 means Sp3, and Sp3 means tetrahedral shape. So XeO4 is having tetrahedral shape. Let us solve one more example. Here XeO3. XeO3 is having 3 oxygen atoms in the structure. Now xenon has 8 valence electron. 3 oxygen will form 3 sigma, 3 pi, so 6. 8 minus 6 divided by 2, number of lone pair 1, and hybridization is equal to, out of 6 bond 3 are sigma, 3 sigma plus 1 is equal to 4. 4 means Sp3 hybridization, and friends, Sp3 hybridization with one lone pair is having pyramidal structure. So friends, you have to remember, whenever oxygen is forming both sigma and pi bond, you have to count only sigma bond for the hybridization, as pi bonds are not formed from hybridized orbital. They are formed from unhybridized p orbitals. However, while counting the lone pair, you have to consider both sigma and pi. So these two examples are very important. You can solve more example from xenon molecules. Friends, let us have some discussion on charge compound. Whenever charge compound is there, you have to add and remove electron. Whenever there is positively charged compound, then you have to remove the electron, and whenever there is negatively charged compound, you have to add the electron. Positive, remove the electron; negative, add the electron. Let us discuss the example of positively charged compound. Sf6 plus. Iodine belonging to fluorine family, having 7 valence electron. Due to positive charge, 1 positive charge, 1 electron is removed. 7 minus 1, so valence electrons are 6. 6 bonds. 6 minus 6 divided by 2 is equal to 0. So number of lone pair on iodine in If6 plus 0. So hybridization is equal to 6 bond plus 0 is equal to 6. and hybridization is sp3d2, and for sp3d2 we know that it is having octahedral shape. Let us find out hybridization of the negatively charged molecule, that is BRF4 minus. Friends, now here we have to add one electron. We know that halogen family having 7 valence electron, and this one becomes 8 valence electrons, and 4 bonds are there. So 8 minus 4 divided by 2, number of lone pair 2, hybridization is equal to 4 plus this 2, 6. 6 means sp3d2 hybridization, and for sp3d2 hybridization the structure is like octahedral. However, two lone pairs acquire here these positions, and due to presence of lone pairs the shape is square planar. Lone pairs are placed in a such a way that they will create minimum repulsion. And friends, and if we neglect the lone pair, the structure will look like this, and therefore it is having square planar shape. Friends, I hope that this video is properly understood by you. Thank you for watching this video. Like, share and subscribe my YouTube channel for watching more videos. Thank you.